Hello students, so in our last session we have seen on operations on tensors and they were all very basic operations like add and subtract, so we could not emphasize much on it. So today we are going to see the other types of operations on the tensors. One of it is merging. Okay, so the first type of the miscellaneous operations on tensors that you are seeing today is a merge. So as usual, the name itself suggests merge means combining multiple tensors into one tensor. Now, but this is important. Okay, so when I am telling I am merging in it a certain dimension. So what is it you are going to see? I am going to merge two tensors based on a certain dimension. Now, tensors can be merged by using concatenate operation and stack operations. So the concatenate operation, if I go, it does not generate new dimensions, but it is going to only merge amongst existing dimension. So whatever is the existing dimension of the tensors, based on that it is going to merge. It is not going to create a separate dimension for you. If you want to go for it, you can go for a stack operation. So the stack operation will create new dimension for you. Now whether to use a concatenation or a stack operation to merge the tensor depends on whether a new dimension you want to create or not. Okay, so generally if you want to work with the same number of dimensions of the existing tensors, then we will go for a concatenate operation. So let us now dive into the syntax of how do we concatenate or merge two tensors. Now I am using here concatenate. That itself tells me that I am not going to create a separate dimension, new dimension to the thing. I am going to have the same number of dimensions which are already existing. So now here I am going to use the syntax where I invoke a concat method from TensorFlow library, and as a list I have to pass on the tensors that I am going to merge, and then as an axis I am supposed to give the desired axis, right. So the tensor 1 and the tensor 2 are the tensors that you really want to merge, and then what about this desired axis? Now if axis is equal to 0, then you are going to concatenate the tensors with respect to the rows, and if it is 1, you will be concatenating it with respect to the column. So based on what is your requirement, you will be able to concatenate using this particular syntax. So now suppose I consider here a case study. So you have got two sets of data. One set of data consists of information about students' exam scores. So tensor 1 here will give me the exam scores of the student, and then the tensor 2 will give me the information about their attendance records, the students' attendance records. So I have now two tensors which are going to give me two separate informations. Suppose you want to merge these two set of data and to create a unified data for further analysis. So what am I supposed to do now? I am supposed to concatenate these two tensors. So very simple, what I am doing here is I just took a sample data of tensor 1 of exam scores. So as you all know how to create a tensor using a constant function, and then I created another data with tensor 2, and as simple as that, now the important thing is how do I want to merge this particular data set. So suppose if I want to put them column wise, first this and then this, then I am supposed to merge tensor 1 and tensor 2 using concat operator and axis is equal to 1. So suppose if I give axis is equal to 1, now you can see here, first you have tensor 1 and then you have got tensor 2. So as you can see, the resultant shape of the tensor becomes 3, 7. So the first 3 columns are of exam scores, the remaining 4 columns are of attendance record. So thus merging tensors can help you to create a new type of data set for further analysis. So this was one of the case study where you are going to use a merging of tensors. Okay. Now the second operation that I move on to is the opposite of merge, that is split. Okay, so in TensorFlow, split operation is used to split a tensor into multiple smaller tensor along a specified dimension, right. Now, when will be this useful? This split operation will be useful when you have got a single tensor which contains a batch of data, and then you want to divide it further and you want to split it further into smaller batches, or when you want to partition the data into subsets for various purposes such as training, validation and testing. So suppose you have a very big data set and you want to use a part of it for training, a part of it for validation, a part of it for testing, then you would go for split. You are all aware of splitting the data set, right? So at that point you are going to use a split function. So these are the basic ways, basic areas where you can actually use a split function. Now how to do splitting? So this is what a syntax, a typical syntax of a splitting a particular tensor. So you are going to call the split function from TensorFlow library. You are going to the main, the bigger tensor that you want to split into, and then you are going to give the size of the split and then the axis or the dimension along which you want the split to happen. So the input tensor that you want to split is tensor, and number of size, number or size of the split, it can either be actually an integer or it can be a list of integers. Now suppose if this particular parameter is an integer, okay, then it will specify the number of equal size tensors that you want the input tensor to be splitted into. Okay, suppose if it is a list of tensor, then you will be that list is going to specify the size of corresponding output tensors that you want to split into. So again, split can be used for equally distributed splits or unequal splits. Okay. So now again the last one, which is an axis, it is going to specify the dimension along which the tensor has to be split. That is, if axis is equal to 0, you will be splitting the tensor as per the rows, otherwise if it is 1, you will be splitting it as per the columns. Okay. Now quickly moving on and checking how can you use a split function. So here you can see I just created a very simple 3 by 3 tensor, and then I want to split it into 3 equally sized tensor. I want to split it into 3 equal sized tensor. Thus the syntax I am going to use here, I am going to choose a split function and whatever be the name of tensor I want to split, and then you can see here I am just giving here one integer value 3. Alright. So once you just get that, you can see here I am going to split it into 3 equal sized tensor. So the code is self-explainable. So this is how you are going to use an split function for equal splitting. Now suppose you want to go for an unequal split. Okay. So in that case, what did I tell you? The second parameter of the split function should be a list of integers. So here what I am defining as the second parameter as size. So you can see what is the size that I am given. I am given list of integers 2, 1, 1. So I want this particular 3 by 4 tensor, that the parent tensor that I have, I want to split it into resultant tensors, splitted tensors of size 2, of length 2, 1 and 1. Okay. So that's what I am going to do. So here for size in sizes that I have mentioned over there, I will start with the start index and then I would increment it as per the sizes that I have defined of unequal length that I want to split into, and then I append it into this empty list so that I always get printed what is the splitted tensor. So you can see after I split it, okay, list wise, then you can see I have got length of 2. Now important part is, where am I splitting? I am going to split it as per the column. Okay. So I am simply splitting it. You can see 1, 1, 5, 9, 2, 6, 10, shape is 3 by 2, then next one 1, then the last one again 1. So you have successfully split it as 2, 1 and 1. Okay. So this is what I have tried to split it as unequal split tensor. You can try any of the method that you would like for splitting of this particular tensor. So this is what is for merge and split, and there are some examples that I have given in the PDF. You please try and work on merge and split and make sure how you use split for more equal and unequal length of tensors. Just give a hands-on experience on that. Thank you.